Okay, class, welcome to Chapter 1, What is Statistics? And just to kind of give you a preview, there's 15 slides in this recording, and I'm just going to walk you through some of the basics of stats, give you a couple terms, walk you through some examples of, like, for example, what is a population versus a sample. And so just as you kind of go through each slide, you'll hear me making some comments and giving you some examples, just to kind of give you a preview of some of the things you're going to get into this semester. Obviously, stats has a wide, variety of uses. Even though this class is labeled, elementary statistics and has a BUS prefix on it, any major can really take statistics. Even the focus of this textbook, even though it's more of a business-centered type of textbook, you'll find that a lot of the examples and applications that we will go through really pertain to just about any discipline. And as I said, previously, obviously, just about everybody uses stats, whether you know it or not. Even if for example, let's say you went shopping or you're getting ready to go buy an item online, typically you might look at user reviews, and guess what? That's a use of statistics. Let's say, for example, you play the lottery. In a way, you are using stats to maybe look at your outcomes to figure out, what are the odds of winning. It's used a lot in Major League sports. Look at Major League Baseball players. Statistics determine salaries. So, this gives you a little bit of a list of just about everybody, as you can see, has a use for statistics. Okay, one of the first definitions in statistics that you're going to find is that the authors want to differentiate between what's called a descriptive versus an inferential statistic. And a descriptive statistic is basically just a means by which you organize and present random data to basically make it more meaningful. Okay, so, and then in a moment I'll talk about inferential, but basically we'll get into what's called bar graphs and pie charts and frequency tables, because that's really what a descriptive statistic is. And an inferential statistic is basically where you're taking either a sample or a part of a population and you're making some sort of inference about what is in that population. So, for example, if you live in the city of St. Louis and you wanted to get an idea of what did the St. Louis city think of losing the St. Louis Rams, you could go out and take a sample, and based on that sample, make a prediction about what you think the whole population feels about that. And you're going to find that the concept of actually taking a sample is going to be a little bit more popular than actually looking at everybody in the population, just because of cost and time and all sorts of factors that's not going to allow you to observe every population. So you're going to find mostly that a lot of the stuff we look at in this textbook when we talk about statistics will deal with taking samples and making inferences about the population based on that sample. And as you can see based on the slide, samples are used a lot to learn about populations. But I just want to make it clear that, sometimes you do get it wrong. I mean, you got to be careful with a lot of things. How large of a sample should you take? Are you taking a good random sample? Is the sample that you're taking, does it represent the population? So there can be some issues, which we'll get into later on, about using samples. But just remember, because you are using samples, sometimes you don't exactly observe a good sample that could represent the population, and then you could make decisions and predictions that actually are incorrect. That could happen. Okay, continuing on some different types of terminology, we're going to talk a little bit about what they call variables, or later on, sometimes we refer to these as outcomes or variables. And notice there's basically two categories. One's called qualitative, and the other one is called quantitative. Okay, qualitative are typically associated with categories or attributes and are typically non-numeric. And here's some examples down below of what would be an example of what's called a qualitative data. I'll just give you another one. Let's suppose you're filling out a survey and you get a question, are you a U.S. citizen? And the response would be yes or no. The response yes or no would be a qualitative attribute. Moving down to quantitative, notice that's numeric information, And I want you to think of is just keep it simple. Quantitative variables, ask the question, how much or how many? It is always numerical. Okay, and then once you have, kind of got the concept of what a quantitative variable is, there's basically two types. One's called a discrete variable, and the other one is called a continuous variable. And I believe it's chapter 6, we're going to talk about the discrete variables, and in chapter 7, we're going to talk about the continuous variables. That's when we get into like the bell-shaped curve and normal distributions. Discrete variables is when we'll get into, we'll talk about what's called a binomial distribution or a Poisson distribution. And we'll worry a little bit more about how to apply those at that point in time. But think of discrete as basically having a finite number of outcomes. Like for example, the number of bedrooms in a house and the number of hammers sold at a local Home Depot had a finite number. Whereas a continuous variable typically assumes different ranges, infinite number of ranges between specified ranges. And I like to think of age, height, or weight as examples of continuous variables. And I believe this is a really good table just to kind of give you an overview of the type of variables. Notice you've got again qualitative, quantitative, and they give you the different examples of some attributes down here for the qualitative variables. And then for the quantitative variables, notice you have it split up between discrete versus continuous, and they just give you some examples. We're going to be studying each of these in detail, discrete in chapter 6, and then continuous. Really, the rest of the textbook is based on continuous, but we're going to spend a couple chapters just going over how to do the probabilities on discrete versus continuous variables. And guys, that's basically it for chapter 1. I actually misspoke. There's just a couple more slides on here. I do want to mention this. The textbook does walk you through not only the types of data, types of statistics, but they talk about what they call 4 levels of measurement. One's called nominal, interval, ordinal, and ratio. I will not test you on any of these. You can review these just in terms of concepts. It might help you determine the type of data or how you're going to actually collect the data. But I wouldn't stress too much about actually applying or having to be tested on any of these 4 levels of measurement. So basically kind of like an FYI.